In the fifth and final part of this video on recursion, we will discuss fractals and show how they can be drawn using recursion. We begin by describing fractals. They are self-similar geometric objects, which means each part has the same structure as the whole object. A recursive definition is a natural way to describe the self-similarity of fractals, so it is not surprising that recursion can be used to draw fractals. Actual fractals are a mathematical concept. The self-similarity recurs at progressively smaller scales. But when we draw fractals with a program, the drawing stops once the resolution of the monitor is reached. Next, we describe the fractal image that we will use in our program example. The fractal image will be a square inscribed in a circle. Then in that square, we will inscribe another circle, which in turn contains another inscribed square, and so on. Shown below is a square inscribed in a circle that also shows how we calculate the length of the side of the square from the radius of the circle. We begin using the Pythagorean theorem to show the relationship between half the length of the inscribed square and the radius of the circle. Then in several steps of algebraic transformations, we solve for the length of the half side. Let's now look at the code required to draw this fractal image. We made the class drawing that provides the drawing panel a nested class inside the class square and circle that defines the window. Note also that it is declared a static nested class because it does not require any access to the instance variables of the outer class. The paint component method simply initiates the recursive method draw, supplying the initial radius of the circle. Scrolling down to the recursive method draw, the recursion stops when radius is reduced to 0, which is the base case. This assignment contains the formula we discussed earlier, which computes half the width and height of the inscribed square. Next, the coordinates of the upper left corner of both the circle and square are computed, ensuring that all circles and squares have the same center point. Next, the solid blue circle is drawn. Then the red square is drawn on top of it. Finally, a recursive call is made. The new value for radius will be the value of half side, so that the next circle will be inscribed in the previous square. Notice that this method is tail recursive, so iteration could have been used just as easily instead. Finally, let's scroll down to the constructor of the outer class. It simply adds an anonymous instance of the drawing class to the window. Now let's run this program. Notice the simple fractal image that this program creates.